Glad somebody's excited. Is my blue light on? Kmart blue light special. All right. Awesome. Uh-oh, I don't have my parabola up there. Where am I? Oh, there it is. Doesn't help a lot, but it tries to get rid of the thudding when I hit the pen on the glass and all that. All right, let's get rolling. Relations and functions. It's exciting. Aren't you excited? You're a year older now. It's even more exciting now. Yes. Should be. All right. A relation is a set of ordered pairs. Ordered pairs. Remember, there's an order to things. So x's come first, then come the y's. Why? Because that's the way it is. So again, notice the ordered pair in set B. Guy 1 is with girl 3. Guy 4 is with girl -1. Guy 7 is with girl 5. Yes. And in B, again, there's an order, right? All of the first ones are in red because they're all the X's, and all the second ones are in green because they're all the Y's. And so there is an order, and you've got to remember that order. All right, some terms. So the set of all first elements, and remember, every first element is an abscissa. I didn't come up with that word. We did learn it back in pre-algebra, abscissa. It is something you should know. But all the abscissas collectively together form a set called the, do you remember? A set called the, all right, domain. All right, so we got to reconnect to last year. And remember that all the first elements, all the x's, all the abscissas, put them together, we call it the domain. Okay, so all the x's together are the domain. So if they said to you, give me the domain of set B, that's all we're saying right here. Don't let the notation scare you. We're just saying, give me the domain, the capital D, and then the subscript B for set B. So you're simply going to list all the first ones, right? The 1, the 4, the 7. Makes sense? And don't forget, they always go in braces. So I provided the first brace, you provide the ending brace, and it's the set 1, 4, 7. 1, 4, 7. Remember, if there happens to be a repeat, we would not repeat the listing in the domain. Okay, so if anything's listed more than once, you'd only list it once in your domain. In this case, they were not. So second domain would be, go ahead and finish it off, pretty simplistic. Write the domain for set K. And again, things are color-coded, so it should be pretty easy. Like -1, 2, 3, 5. Don't forget to close the braces, right? Always put your sets in braces. Domain. All right. All the second elements, and a second element is called an ordinate, or, anybody remember the other word? Image, right? An ordinate or an image. And collectively, when you put them all together, all the Y's, all the ordinates, all the images, you get a set called the range. Come on now, domain should have triggered your memory for range, right? So you got domain and range. All the X's is the domain, all the Y's is the range. That's why we have a capital R down there. So the range of set B. All right, I got to go back up here and see set B. And you can put them in order that they come, or you can put them in numerical order. Most prefer numerical order. That way you don't have to go looking around to make sure you got them listed correctly. So most prefer numerical order, but some just stick them in the order they come. All right, so finish off the range for set K. Write the range for set K. And everybody says the range is? Let's say it. Not 4, 4, 7? Because you don't repeat anything twice, right? Because 4 is 4, and you've already included him, actually her. And so she's included. We're good to go, right? Relations. Remember, a relation is a set of pairs. If everything is not paired up, it would not be a relation. Let's say you have a set and there are 50 pairs and then one single X all by itself. Don't have a relation. Let's say you got a set, you got 139 pairs and one Y all by herself. It's not a relation. Everything's got to be paired. So if everything's paired, it's a relation. Everything paired, it's a relation. Domain, all of the first elements, the X's, the range, all of the Y's. And that will go for whether it's a relation or a function. So remember, a function is a special relation where each X coordinate is paired with 1, and this is a math term, and only 1 Y coordinate. 1 and only 1 Y coordinate. So, for something to be a function, it has to first be a relation, meaning everything has to be paired. However, in addition, there's an additional condition to see if this relation is indeed a function. And that is, does every first coordinate, the X, have only one Y? Does any abscissa have only one ordinate? Or, if you want to make it real easy, is any guy dating only one girl? Got it? Pretty simplistic, right? The X's are guys and the Y's are girls. Any guy can only date one girl. So no guy can date more than one girl. No guy can date more than one girl. All right, and that is the order of things. Guys go first, girls go second. If that is the case, then indeed you have a function. There should be a comma between the 1 and the 3 in set B there. So if you look at set B, 1 is with 3. Is 1 with anyone else? No. 2 is with -1. Poor guy. He had to go into the negative range to find a date, but it's just the way it goes sometimes. All right, 2's with -1, and 3 upgraded to 5, and that's a pretty good deal there. And that's the way it goes. Right, so that is a function, right? Any guy is dating only one girl. Any abscissa has only one ordinate. Right? Any X has only one Y that it's with. If that's the case, then we have a function. And let me remind you guys of what really this means. Again, if you go back and think about a computer, the X's are the inputs. The domain is the input. And the range is the output. So if in this program, if you inputted a 1, the program would output a 3. This would give you out a 3. In this program, if you input a 2, it would output a -1. And if you would input a 3, it would output a 5. And because it's a function, it always knows what to give you out. Because there's only one possible out for any in. Any guy's dating only one girl. So we know. I don't know if there were any relations in here. Are there girls? The girls would know. Nobody? All right, boring class. But you're young, so. Let's see. What about in the school? Are there even any in the school? I'm trying to. There's not a whole lot going on right now, is there? Is there? Oh, yeah? We're always the last to know. All right. So if I were to throw out a guy's name in one of those situations, you would know. What's it? Shane? If I throw out Shane, is there anything working there? All right, no. He's working on a lot, but nothing working there. All right, just wondering. Let's see, what guy can I throw? I got to think a minute here. How about Brian? What if I throw out Brian? Don't know? All right. You guys don't know. All right. All right. I'm going to leave it because we will. So, second situation, set K. Again, negative ones with 0, twos with 4. Uh-oh, threes with 4. Is this not a function? Is it a function? But 4's going with 2 and 4's going with 3. A girl can date 2 guys or 3 guys or 5 guys or 8 guys or 10 guys. It'll still be a function. And again, why? Think about input and output. If I input a negative 1, what does the program give me? It knows what to give me, right? If I input a 2, what does the program give me? It knows what to give me, doesn't it? If I input a 3, what does it give me? It knows what to give me. See, there's a definite output for any given input. That's a function, and that's fine. Now, in real life, you want to know how it works? No guy can date more than 2 girls, and here's why. All right. He will get caught because if a guy is dating more than 1 girl, girls are always talking about these kinds of things. Who's dating who? And they know all of what's going on. So if any guy tries to date 2 girls, he's going to get caught. It's going to be found out. There's just no way he's going to keep that under the rug. He'll be nabbed, and then he'll be dating nobody, right? Because that's how that happens. And however, if a girl is dating 2 guys, will the guys ever know? Usually, nah, they're worried about the Cavs game last night or the Rams whooping up on the Seahawks or, the level in their video game. Girls, I hate to say what you have to look forward to, but oh well. All right, so it works. No, really, any input gives you a definite output. J, the same situation. Not a problem. Every guy is dating a different, has only 1 girl that they're dating. Look at number 4, set Z. Girl 5 is dating all 4 of those guys, but you know what? It's okay. It works. Because if I input a negative 1, I know to put 5 out. If I input a 0, 5 out. Input a 1, 5 out. Input a 2, 5 out. All right. So, thankfully it's not marriage, otherwise that would be trouble, but that is the case. All right, so remember, any first element can have only 1 second. Any guy can date only 1 girl. If that's the case, you have a function. Next, we got to talk about and refresh your memory on functional notation. We talked about it last year, but just a little bit. Functional notation is simply a language. It's a math language. Now, if I say to you, at Everturchi, most of you know what I said. How many know what I just said? None of you? All right. That's like a normal. Yeah, all right. If I say to you, sayonara, how many know basically what I'm telling you? Okay. All right, but that's a different language. All right, whereas if I say adios, adios, you know that one, all right? So we're getting things a little bit more familiar. But they're different languages. I say goodbye, all right, you know what I'm saying. So functional notation is just a language way. So don't let functional notation get you scared. It's not a big deal. Normally what we'll have is a lowercase f. However, we can use other letters if we want to show you more than one thing in functional notation. But normally it's an f in front if we don't need to show you more than one. And we'll put in parentheses either a variable or it could be a number. Could be numbers of things. In this case, we're going to put an x because that's the normal way this goes. And the way you would read this is f of x is the way you would say this, f of x. It's really shorthand for a function of x is the equal sign 3x plus 1. A function of x is 3x plus 1. But here's how simple this is. So let's write a few things. I'll come back to that and we'll get to that. So let me put it a little higher. So f of x represents the dependent variable. F of x represents the dependent variable. Okay, so we have x's and y's, correct? The x's are the independent variable. And the y's are the dependent variable. So the f of x simply represents the dependent variable. That's all it is. It's just really a shorthand notation. So if I wanted to, I could come up here and where f of x is, I could write y equals 3x plus 1. It would be the exact same thing. You know, the y equals 3x plus 1 would sound normal to you guys, normal language, where the f of x is functional notation, functional language. You're not familiar with it too much yet. But it's not hard. It goes in place of the y. Right? And there's a value to it, and we'll get to it here in just a moment. All right? So the y, the dependent variable, and f of x are interchangeable. Therefore, regular notation would be y equals 3x plus 1, right? That would be regular notation, non-functional notation, functional notation f of x. You say, well, why don't we just do y? Let's not even fool with this f of x. Well, mathematicians are notorious for shortcuts, and we want to be able to quickly do something that is a shortcut. And so because of that, we do a notation like this. So for coordinates, instead of x and y, we can write f of 7 equals 22. You know, all this means is the x coordinate is 7, and the y coordinate, therefore, is 22. That's all that means. If f of 7 equals 22, 7 is the x, and 22 is the y. Guy 7 is dating girl 22. We're just showing you the relationship there. If you were to write this as an XY chart, you can do it two different ways. You could do x, and on the other side, you can do f of x. Or you can do it, remember, f of x and y are interchangeable, so you can go y instead of f of x. This is two different views of the same thing. This is functional language, and this is your normal thinking language. Okay? But it's the same thing. Just like ciao and food, Navy term, and or ciao in Italian would be goodbye and goodbye. Two different ways of looking at the same thing. So in this case, the x would be 7 in both cases, right? And what does it equal? In both cases would be 22. All right, again, I know that's a little vague to you right now. I understand that. Functional notation tends to get students a little bit in the beginning because it is a language. It's a math language. And as we deal with it more, it should become clearer. And hopefully I'll try to help you out a little bit here as we go. Okay, so let's take a look at D. And let me get my shade back up here. All right, so for the function, we've got a function up there. And by the way, is it a function? Is any guy dating more than one girl? And the answer is no. Right? No guy is dating more than one girl. So if they ask you to list a domain, somebody raise their hand, tell me the members of the domain. Go ahead, Josh. Okay, and I'll just put them in order because it's easier to do it, and you set them in order. -3, 0, 3, and 5. And those are my domain. And somebody give me the range. Somebody give me the range. Byron, go ahead. 2, 4, 9, right? And Byron did not repeat the 4 because, again, you're only going to list it once. All right. So, you know what? Believe it or not, on the first quiz, a question like this right here, number 3, is going to get you guys. Don't let it get you. It's really an easy question. Can anybody tell me the answer of f of 3? Anybody give me the answer? F of 3? Connor? Really? 4? How many agree with Connor it's 4? Yeah, you know what Connor did? He went up here and looked for the 3 and saw who 3 was dating. That's all. That's all that is. Because they gave us the set of pairs, all we had to do was find out who guy 3 was dating, and it was girl 4. So therefore then f of 0 equals 4, right? Girl 4 is dating both of those guys, so they happen to both be a 4 because, again, you looked up to see who 0 was dating, and it was 4. So in that kind of a situation, functional notation allows you to do that. There's a lot more value to functional notation. Don't write this. I'm just going to show you where we're heading with this. If I gave you a standalone problem, again, don't write it. I'm going to be up here in this box. And let's suppose I said something like this. F of 2 equals 3x plus 3. Could you tell me what girl guy 2 is dating? Say it if you know it. It is girl 9. How did Connor know girl 9? Because Connor knew that functional notation says put the 2 in for the x and solve the little equation. So 6 and 3 is 9. Guy 2 is dating girl 9. And that's really how we're going to mostly use our functional notation. So I didn't have to do a big explanation. I simply had to just give you this, and you know now to figure it out that it's equal to 9. That's really where we're heading with functional notation, and that's really its value. Something like this is just trying to get you to connect things, and we'll deal with that a whole lot more in just a little bit. Okay, so relations and functions, by the way, there's an extra in relations in there. Relations and functions can be represented 4 ways. Written as an XY chart is one way. Written as an XY chart. And let's just go right down to it. So you can see number 1 there corresponds to number 1, right? Right here. And so, hey, I can write it as an XY chart. So, who are my guys? -1, 0, and 2. By the way, is our example a relation? Is it just a relation, or is it also a special relation called a function? Which is it? Just a relation, right? Because guy 2 is dating 2 girls. Let me go back real quick to my input-output analogy for something. This is not a function, correct? So look, in this, if I input 0, what does it output? If I input 2, what does it output? No, it doesn't. It doesn't know what to output. It locks up. Just like if your programmer in your video game messed up a little bit in his programming, didn't anticipate a certain combination of your controller that gave it more than one possible output, it doesn't know which one to give you. If there's 2 or more outputs, how can it decide? It's just a machine. It doesn't know what to give you out. It can't decide which one, and it locks up because there's no definite output for a given input. That's not a function. If a programmer writing code, Ashton, had that situation, then he'd have to debug it. Have you ever gotten patches to your games? You know what they did? They found some bugs. They found some situations where it wasn't a function. There wasn't a definite output for a given input, and they fixed it so the game wouldn't lock up. Your program wouldn't lock up. That's the situation there. All right, so, and then if we put in the y's, so -1 is with 3, and 0 is with 3, and 2 is with 4. And you know what? On this one, on the XY chart, we got to list the second 2 again, because it's an XY chart, because we got to show all the relationships. And then 2 is with 5. So in your XY chart, you'll have the 2 there more than once because you got to show all the relationships. Okay, number 2 is set notation. So we'll do this below. So number 2, set notation. And set notation is really the way it was already. So all I'm doing is copying what's up above because it's already in set notation. And I'm just going to write etc. It's the exact same thing, right? It was already given in set notation. In number 1, we took it from set notation and wrote it as an XY chart. So again, set notation is the way it was already. The third How can you show a relationship or a function? You can show it with a Cartesian plane. What's the other name for a Cartesian plane? Also called a coordinate plane, right? Same thing. Hey, what would you do with this? You would plot the points. So let's go negative 1, 3, 1 left and 3 up. Put a point. 0x and 3 up. Put a point. 2 to the right and 4 up. Put a point. 2 to the right and 5 up. Put a point. So you plot the points. So 1 left and 3 up. No left or right, 3 up. 2 right and 4 up. 2 right and 5 up, right? We would plot the points. And the last situation is a mapping diagram. Mapping diagram. With your mapping diagram, guys, you should indicate the domain either above or below and the range. Because the first is the domain and the second is the range. So what are our guys? Negative 1, 0, and 2. What are our girls? 3, 4, and 5. Here again, we wouldn't repeat anybody twice. Now, don't neglect this, and some of you guys forgot to put an arrowhead on your arrows, but the mapping is showing who's with who. Negative 1 is with 3, correct? So we have an arrow from the negative 1 to the 3. 0 is also with 3, so we have an arrow from the 0 to the 3. 2 is with 4, so we have an arrow from the 2 to the 4. And 2 is with 5, so we have an arrow from the 2 to the 5. You got to have the arrow. Remember, it's always guy to girl, independent to dependent, X to Y always. And so the arrow always points to the girl the guy is dating. Got it? All right.